All right, hello everybody. We are starting chapter 7 tonight, which is going to have a whole lot of different formulas of different trigonometric identities. And the good news for you all, since you can use notes on your exam, is you do not necessarily have to spend an awful lot of time and energy trying to memorize these formulas. What I do expect is that you can find them, know what they do, and know how to use them. And frankly, in this day and age, I would say that is probably a more important skill just generally, because there is no shortage of information that's out there. Finding good information and using it correctly is a much more relevant skill to the 21st century world in which we find ourselves. So without any further ado, so again, this is section 7.1, and it has to do with trig identities. So here we have a very lovely laundry list of all the different trigonometric identities that we have seen in different ways. There is the main Pythagorean identity that we talked about once upon a time, sine squared plus cosine squared equals 1. There are two variations of that. There's one where you have 1 plus cotangent squared equals cosecant squared. And then there's this final one, which is 1 plus tangent squared equals secant squared. And these formulas, by the way, are actually why secant and cosecant are defined the way they are. It, I think, always kind of annoys and baffles students that if you, and it's actually down here, you know, cosine is the reciprocal of secant. And a lot of people think that it would make sense if cosine went with cosecant. But with where these formulas come from, and these due to reasons, these formulas kind of predate a lot of concepts in mathematics because they have a lot to do with geometry at their heart. And so this, you have the cotangent together with the cosecant. And this is the formula which kind of links them together, which explains why they are defined as they are. And then this one, you have secant and tangent together. We talked about the even and odd identities. Cosine is kind of the odd one out. Cosine is an even function, as is its cousin secant. If you put a negative angle into cosine, it ends up being equivalent to just, you know, sine of negative 30 degrees is the same as sine of 30 degrees. The negative sign, putting it inside the function, is meaningless, basically. When it comes to the other 4 trig functions, particularly secant, or I'm sorry, particularly sine and tangent, those ones, if you negate the angle, it negates the value of the trig function. We've talked about the reciprocals a whole lot. And then we have also mentioned that tangent is defined as sine divided by cosine. And then by extension, if you do the reciprocal of tangent, that gives you cotangent, which therefore means that the cotangent is cosine divided by sine. So again, this is just sort of one-stop shopping for any and every trig identity you could possibly ever want to know. And what this section is going to be about, we're going to do just a few sort of highlights from it. But the gist of this section is that we're going to simplify trig expressions and try to make them a little less huge and use these different identities and formulas to try to make them easier to work with. So this first one here, they say verify that tangent cosine equals sine. So let's start with that first. And the general rule of thumb, a good idea for a lot of problems, is get everything in terms of sine and cosine. So with a lot of problems, this typical strategy will help the vast majority of times. So for instance, tangent is sine over cosine. If you change it to its definition in terms of sine and cosine, we are then multiplying that by cosine theta. And if all goes well, that should indeed equal the sine of theta. Now, fun fact, I'm dividing by cosine and subsequently multiplying by cosine, which means those are going to cancel out. And so then lo and behold, all that is left when all is said and done is sine theta. And that, as you can probably guess, is equal to sine theta. So that checks out. We have indeed showed what we set out to show. Tangent cosine is in fact equivalent to just sine. Here we have another one that's very similar to this, and we're going to use the same strategy. So cosecant of theta. What is cosecant of theta? Well, that is 1 over sine theta is what that is. We're going to multiply it by cosine of theta. And then we're going to change tangent, just like we did before. Tangent is going to be sine of theta over cosine of theta. And then if all goes well, that should just simplify to 1. Now, if we look, we can see kind of a lot like the last example here. You've got sine on the bottom and sine on top. Those are going to end up canceling each other out, just as if you were reducing fractions. Meanwhile, here's cosine and cosine. Those are going to end up canceling each other out as well. So then what this will end up giving us is that 1 is in fact equal to 1. How about that? Who knew? So there you have it. Those are some examples of using trig identities to verify and check that that the two sides of the equation are in fact equivalent. Here we have another one. They say verify the following equivalency using even-odd identities. So what you will notice, here we have sine negative x. So back on that slide, a couple steps back, sine negative x, you might recall, that is equal to negative sine of x. So the first thing that we're going to do is say this is 1 plus sine of x, and then multiplied by 1 minus sine of x. So we are going to rewrite this, and then if all goes well, that should equal cosine squared of x. Now, this right here is a job for FOIL. We're going to multiply the binomials here first, outside, inside, last. So we're going to use the FOIL technique that you've learned previously. Here we're applying it to a trig problem. So for the first pair, you've got the 1 times 1, which is 1. 1 times negative sine x is just negative sine x. Sine x times 1 is plus sine x. For the last terms, if you do a positive times a negative, that is negative. Sine times sine means sine squared of x. And this is equivalent to cosine squared of x. Fun fact, if you combine the like terms, negative sine x plus sine x is going to end up canceling out. So this gives you 1 minus sine squared x equals cosine squared x. And then another identity that is relevant to this particular problem, and the thing that maybe ideally would make this a little more obvious. So the clue is the sine squared and the cosine squared. The Pythagorean identity says sine squared theta plus cosine squared theta equals 1. And so if you have a 1, you can replace it with this, sine squared theta plus cosine squared theta. So instead of 1 right here, I can write sine squared x in this case, plus cosine squared x, and then minus sine squared x. And what that does for me, you see now that we have a sine squared x minus sine squared x. So those end up canceling each other out. And lo and behold, cosine squared x equals cosine squared x. And we're done. We have shown what we set out to show. Those are, in fact, equal to each other. All right, next. Here we're verifying this identity, secant squared minus 1 over secant squared is equivalent to sine squared. If we go back to this identity right here, 1 plus tangent squared theta equals secant squared theta. So let's go ahead and start with that. 1 plus tangent squared theta is equal to secant squared theta. That is one of the versions of the Pythagorean identity. So secant squared is equivalent to, so we're going to replace this secant squared right here. So that's going to be 1 plus tangent squared theta minus 1, all divided by secant squared. And then when all is said and done, we should end up with sine squared. So fun fact, here is a 1 minus 1, which is going to make those cancel out. And then I'm actually going to write this a little bit differently. I'm going to call this tangent squared theta divided by secant squared theta. So instead of writing it as a fraction, what I'm going to do is write it like it's a division problem. Now, as before, a good rule of thumb, a good piece of advice when you're doing these kinds of problems is to try to get everything in terms of sine and cosine whenever you can. So for tangent squared, that is just going to be equivalent to sine squared theta over cosine squared theta. Meanwhile, we are dividing secant squared. Remember, the definition of secant is 1 over cosine. So since it's secant squared, this is going to be 1 over cosine squared of theta. And then something to recall, this is a little blast from the past here. If you are dividing fractions, so if you're doing, I don't know, 2/3 divided by, I don't know, a half, I guess. Sure, what's a half? What you're supposed to do is you're supposed to do 2/3 times 2 over 1. So when you are dividing fractions, you're supposed to change it to a multiply problem and then flip the second fraction and do its reciprocal here. So what we're going to do, this is just sort of a, quit drawing lines through it. This is just sort of a little reminder about fractions here. So what's going to happen is we're going to do sine squared theta over cosine squared theta. And we're going to multiply and make this cosine squared theta all over 1. And that equals sine squared theta. And we're basically finished at this point because, like before, lo and behold, cosine down here and cosine down there, they're both cosine squared. They end up canceling each other out. So what you're left with when all is said and done is sine squared theta equals sine squared theta. And there you have it. That checks out. Those are indeed equivalent expressions, which is what we were trying to show in the first place. We have one last one from this section. They say show that cotangent theta divided by cosecant theta is equivalent to cosine of theta. So I'm going to use a similar strategy to what I did earlier. Cotangent theta divided by cosecant theta. So I'm going to rewrite it as a division problem instead of a fraction. And so this is equal to cosine theta. Cotangent, remember, that is cosine over sine. That's the definition of cotangent. Cosecant, you may recall, that's 1 over sine of theta, because it's the reciprocal of sine. And then we did this trick before, but when you are dividing with fractions, you're supposed to multiply the reciprocal. So that means we're going to do cosine theta over sine theta, and that will be multiplied by sine theta over 1. And then as before, sine will cancel out with sine. And after the chips have fallen, this tells you that cosine theta equals cosine theta. Imagine that. And there you go. We have successfully shown that those are indeed equivalent statements. So that is all the highlights that we're going to do from section 7.1. And so big idea is be familiar with some of the different trig identity formulas, and then have some tricks up your sleeve for how to tinker with more complicated formulas to take something that looks really complicated at first and kind of shrink it down to size so it's a little less intimidating. And again, the best advice that I have is if you get everything in terms of sine and cosine only, that usually will take you a long way towards solving most of the kinds of problems you will see. So that is the end of section 7.1. So go ahead and stop the recording here.